Hey everyone, this is Nick, the EMF guy Pinot, and my goal is to spread awareness about the dangers of electromagnetic fields, EMFs, emitted by modern technologies, and to spark innovation towards the development of safer tech. I am an investigative health journalist. I am the author of the Non-Tinfoil Guide to EMFs, which is available on all good stores, Amazon worldwide, and also the Electrosmog RX EMF course for health practitioners, which you can find at electrosmogrx.com. And welcome to one of my exclusive interviews on this YouTube channel. And this time I'm interviewing someone I already had on the channel about 6 months ago. And time flies by because I can't believe it's been 6 months already. And I think that this was possibly my best interview I've ever done, to be quite honest. And it was with Pawel Wypychowski. Pawel, thanks so much for being back today.
Thank you, Nick. Appreciate being here.
And to give some context, let me read some parts of your bio for viewers who might not be familiar with your work, and make sure everyone, if you're listening to this second interview, I want you to listen to the first, because we did almost an hour and a half looking at exactly why is it that EMFs, these man-made EMFs from Wi-Fi, from Bluetooth, from cell phones, these frequencies that our human biology are not attuned to, how is it possible that they interfere with normal body function? And Pawel has an engineering background that I found so interesting in the way he explained it, that just made so much sense, how it's jamming your body system, the natural frequencies that our brain operates on, for example. So it was beyond fascinating. But to give you a little bit of background, Pawel is a graduate in electronics and telecommunications of the electrical department of, I cannot pronounce this, Szczecin University of Technology. How do you pronounce that?
Yes, that's right.
That's right. Oh, Szczecin. Okay. Well, my Polish is not rusty after all. So you've been involved with tech company.
Better and better.
What's that?
It's becoming better and better.
Yeah, with time. That's incredible. I have an ingrained talent for that. Amazing. Well, you've been involved with tech companies since 1990. You've been even managing one of the first commercial internet service providers in Poland for several years, and then working as an independent IT consultant. So let's say that you have a background in telecoms, so you're part of in the EMF space. People look at like, okay, it's us versus them. Well, you're part also of people who launched the telecom service and this technology. But in 2017, you experienced yourself a slew of symptoms. You went into your story in the first interview related to this heavy usage of wireless, and then you became an activist for safer tech, establishing electromagnetic safety company called EMF3, EMFbusters.pl, and you even helped create the Foundation Institute of Electromagnetic Research, James Clerk Maxwell in Krakow. And today, I'm talking to Pawel again because he sent me information that completely blew my mind, as you tend to do. That's something that you do. And let's go right into it. The first part of our discussion, let's start right now, is about what 5G really is. Because you told me, Nick, in several podcasts, interviews, media outlets, I hear all sorts of crazy things about 5G. And a lot of people, what they're saying is not accurate about what 5G really is. So if you want to start, I think the best place to start, because people are going to find this video from all backgrounds, all walks of life. Some people have never heard about 5G. So just let them know what 5G is, and let's get into the confusion and try to clear things up a little bit here.
Okay, I would like to start to make this. I would start with the statement that the 5G is really not a revolution. It's rather an evolution not in technology as such, but in consumer technology. I make a certain distinction between the technology, scientific technology, and consumer technology. Consumer technology is focused on selling. Okay, technology in science is focused on better understanding the nature, making the measurements, making the technological progress. Here with the consumer technology, we are focusing on making the business, not the scientific progress.
Selling more smartphones, selling more stuff.
Yeah. So first, I would like to start. I would like to show you some slides, very simple one which I prepared. So 5G, let's say, drivers, okay, main driving forces for the 5G. First of all, it's growing consumer demand for high-speed transmission, and 4K and 8K videos is estimated to be 80% of the traffic. Wow. So it means basically that consumers like to use like to watch videos on their smartphones, and this is 80% of the need for 5G. Okay. Then the second driver is the idea of having the wireless connection everywhere. Mm-hmm. So it means Internet of Things, so each and everything really connected bikes, cars, buses, trains, airplanes, and not only to the internet, but also vehicle-to-vehicle connection and vehicle-to-infrastructure connection. It includes road, railways, and satellite connections. Okay. And the third one is really on the side of the telecom industry. It's more efficient, dynamic bandwidth management for telecom service providers. It's because telecom service providers simply pay for bandwidth to the government. Okay, they simply buy frequency ranges, and they want to use it in the most efficient way to make money. Okay, to really be able to, at the same time, to provide services to as many customers as possible, and to bring them as fast service as possible. Okay, so these are the main drivers of 5G. So what 5G is in terms of frequencies. You have here the slide, because most people make a connection between the 5G and only the millimeter wave range. Okay, it's really not like that. It's actually, as you can see here, it's the first so-called frequency range 1 is below 7 gigahertz. And the ranges here, you have United States here, Canada, United Europe, Great Britain, and so on. But we can see here that the main ranges of the 5G are 600 megahertz bands, and then 3.4, 3.8 gigahertz band, so below 4 gigahertz band, and also some unlicensed bands between the 5.9 and 6.4 or 7.1 gigahertz, which already are used by Wi-Fi connection in the higher ranges. Right. So this whole spectrum is actually the current spectrum we are using. And this will be used in the 5G, and the most of the today's pilot installation of the 5G will be in that range. So it will be no millimeter range frequencies.
And just to give some people,
especially when we are talking about the mobile stations, because if you want to use the current infrastructure, meaning the towers, okay, of the base station, you have to use this range, because you cannot reach with the millimeter range so far. Gotcha. Okay, and this is really the limitation of the millimeter range, which I will explain in a short minute. But then we have the frequency range 2, which is between 24 and 71 gigahertz, and this first frequency range is focused on coverage, so the distance which is covered by the infrastructure. Okay, so if you have the base station, with those lower frequencies, you can cover a lot of space. But you cannot really deliver the fast rate of transmission to many consumers at the same time in this range. So there is another range and jump into millimeter wave for where focus is on capacity and data speed. Okay, but the range is much shorter. So the basis for that looks complicated, but I try to explain it in a very simple way. This is called Shannon law, and Shannon law is actually a law about the limits of information rate, which is here as C at the left side of the equation. And basically, not going into details of this equation, it means that if you want more capacity in the channel, so faster speed rates, you need to extend the bandwidth, which is B. The bandwidth is actually the range of frequencies you are using. So if the range is increasing, it means like you have a kind of a highway for information. So more lanes.
More lanes. Okay, that makes sense.
More bandwidth for that. So you can extend the bandwidth if you want faster rates, but then another thing you have to take into account is the signal to noise ratio, so S to N, and this is meaning this is the quality of the channel. So you actually have to take into account also the ability of the receiver to detect the signal over the noise in the environment. Okay. And the noise is also other channels and other devices emitting and so on. And the noise is also the space, because the free space, because usually the signal is attenuated when it travels through the free space. Actually, the air is not a good conductor for the information and for electromagnetic energy. We use it mainly because of convenience. Technically speaking, fiber optic is billion times more efficient.
Because all this extra signal is lost in the air, mostly.
Yes, it's actually lost in the air, and in our bodies, it's attenuated, yes. And it's simply in energy terms, it's lost. Okay, right, in energy terms, it's lost. It's used to increase the temperature of the whole space and so on. Of course, the temperature rise is very tiny, but the whole you can say the whole free space now around the Earth is shaking. Okay, with those frequencies, because it's really a lot of that comparing to what it used to be in natural environment. And you have to trade actually the bandwidth and the signal to noise ratio for speed. And the example which I bring here, because it's important to understand, is that in an outdoor environment with just free space loss, so it means lower frequencies, it's not true in the millimeter range, then it's even worse. It's like a 6 megabits per second signal, which is not very fast in today's terms, can actually be decoded 7 times farther away than 54 megabits per second signal. So it means that if you want to reach with the faster speeds, then you have more problems in free space to really decode this information in the farther distances from the emitting antenna, and then becomes a real problem in the millimeter wave. And I will show you some additional slides. Okay, 5G millimeter wave, is it really new? And you have here the document from March 1974. Wow. which is atmospheric effects on terrestrial millimeter wave communications, made by S.G. Dudziński, so probably some Polish guy. And this is a report prepared for Defense Advanced Research Project Agency. So we were talking about the millimeter wave communication, at least in military aspects, in 1974. So it's not a technological breakthrough in any way, the millimeter wave transmission. It's just using it for a consumer technology and selling it on a mass scale. It's as simple as that.
Gotcha.
And also, we should know also that the links between the mobile towers are made at millimeter wave communication links. These are point-to-point links only, so one tower to the other tower. But this was already in the millimeter wave like 20 or 25 years ago. So, and
really,
it still is. Okay, yeah.
And
so we are using that already for several decades.
So hold on, are you talking about the 2G, 3G, or 4G towers? They talk with each other with millimeter waves, is that right?
Yeah, but you know, when you have the tower, you have those antennas spreading the signal in all directions. Okay, these are the so-called sector antennas, and then you have the dishes, okay, on the tower. And the dish and the other dish on the other tower or somewhere else, if there is no fiber connection, fiber optic connection, then the dishes, that is communication, point-to-point communication, tower-to-tower communication, through this is a radio link, some called point-to-point. And those radio links are made already in a 60 gigahertz range, for example, in a 40 gigahertz range usually. So this technology is already installed, you know, all over the world, and it's used for like 2 or 3 decades. So this is not something new, but this is only the point-to-point connection.
Okay.
Usually, it does not affect everybody. It's just a straight line. But the one thing to remember is that it cannot be technically just a straight line. It always has an angle, no? And it doesn't end at the receiver antenna. So it goes further. So we are, to the certain small extent, we are already exposed to these frequencies ranges, okay? For like 20 years, 25 years or something, but to the very small extent, because usually the radio link is constructed in a way to not interfere with the houses and anything, because you are losing the connection. You are making simply the poorer connection.
But I just want to summarize here. So what you're saying is that these millimeter waves, which is the equivalent of the frequencies that are used in airport scanners, for example, around 24 gigahertz from what I could gather, maybe there are other models, 30 gigahertz. Well, these millimeter waves that are higher frequencies compared to, let's say, your cell phone right now could use anything from 900 megahertz to 3 gigahertz. A Wi-Fi router would use 2.4 to 5.8 around these, but millimeter waves are higher than that. And you say that they've been already kind of polluting the environment with millimeter waves for 30 years, and that even if it's very low level, well, again, we don't know what it's been doing to us, and the technical aspect, I think you'll talk about it, is that these millimeter waves are hard to detect on a consumer level with a meter because it's in the higher frequencies. But I'll let you go. This is fascinating.
That's correct. And also the quick view at the attenuation actually of the millimeter wave in the air, in the atmosphere of the Earth. And you can see that the attenuation it's actually higher in the range because of the water content in the air, and also with the phenomenon of resonances and absorption by the oxygen. Okay, so you have very high peaks for oxygen here. It's like about 60 gigahertz and about 30 gigahertz for water simply, or moisture in the air. Okay, so this is the big limitation for the gigahertz, for the, let's say, millimeter wave range, that we have a very big attenuation in the free space. Okay, so we cannot reach very far. So what does it mean? It means that if the millimeter wave 5G communication is going to be installed in some area, then you need a lot of base stations. It would not look like the base station as today. It would not be tower. It would be something like the size of a book. But it will have to be like each 2 or 3 buildings on the street to really provide the communication. So, and the network provider has to really pay for it, for this infrastructure. So this is a kind of a buffer for us, that if you are going into scenario where there is not enough of the recipients who are willing to pay for that, it doesn't make economic sense to install such an infrastructure somewhere. So first, such an infrastructure will be installed in academic campuses, in business centers, those type of places, and in the city centers of the big cities, because then it makes economic sense. In the areas where when there is low, not a lot of people, and people are not willing to pay for that, it does not make economic sense, okay, to install 5G at millimeter wave frequencies. Because also the users of that has to be, the users have to be able to pay not only for the service, but also for the new devices which are ready to receive the signals. So in some way, the economy is on our side.
Yeah, because
if you are willing to leave the city center, okay, but it's,
for sure,
it's of course a tough change, okay, in some ways. Some examples of the 5G, let's say, pilot installations, just to give you a glimpse of what's going on in the industry right now. You can look at the dates. They are not so long ago in time. It's December 6, 2019. Team partners with Ericsson and Qualcomm to demonstrate Italy's first 5G smartphone connection. It's just, no, this is going on right now, okay? And right now it's tested. Here you have 5G, but not necessarily the 5G of the mobile service, but the 5G of this, let's say, Wi-Fi at the 5G 60 gigahertz, so millimeter wave service. This Cambridge Communication System has provided its MetNet 60 gigahertz unlicensed millimeter wave wireless solution for the UK smart tourism project in the historic city of Bath. This is already existing, and you can see here how this 5G antenna in millimeter wave looks like.
It's very small, okay, right?
Very tiny, yeah, and that's it. And it will be installed everywhere in the region where the connection should be, or coverage should be done. So also in the streets, you have these openings in the streets. I don't know how to put it, under the covers, so really under your feet. Okay, it will be installed nearly everywhere to actually provide the coverage in this frequency range. Okay, here you have another example, which is NEC. February already this year, okay? This is 4K and 8K definition videos were transmitted from a 5G base station installed along the railroad corresponding to the 4.5 gigahertz band and 28 gigahertz band to a 5G mobile station located inside the train running at approximately 19 kilometers per hour. These are the new tests because the transmitting the signal to the moving object and receiving it is even more difficult. So they are testing if it's possible to transmit to the fast-moving transport means like railway or even fast cars. Here you have another example, which is 5G outdoor trial with also with the millimeter wave. You can so on here on the building and here on the car are not so tiny here because they are optimized to make this test. So this technology in the millimeter wave, it's under development. It's important to know that even the standards of transmission in this millimeter range are not fully established yet. Okay, so industry is really in the trial mode. And here you have May 11, 2018, another example of the testing of the wireless transmission in the millimeter wave to the car, to the racing car running 300 kilometers per hour. So they are trying, they are testing it, how to provide the link. And here you have how it is really going on in terms of a business, what is already produced and what is predicted to be produced. This is 5G and massive MIMO radio shipments. MIMO is a technique, massive MIMO is a technique used in 5G, which is very important for the biological impact. It's just, MIMO is called multiply input and multiply output. And it means that antenna is not an one element antenna anymore. The usual antenna in a massive MIMO 5G installation is actually made like from, for example, 256 elements, and each element of this antenna is a small antenna, and each of it can communicate with the particular client in the area, forming the beam to the client. So managing where it is. It used to be like the antenna was radiating, or the base station was radiating everywhere. Now it will be the beam to the consumer, not interfering in other direction with the other communications. So it gives and also costing less energy. In a way, I think it's good for us, because it's like if someone now wants to see the video on his smartphone, then he gets more radiation, but not necessarily the other guy which is farther from him.
And I'll have some questions. Yeah, I'll have some questions about that, because I've heard certain things like, is it possible that if I have a smartphone and I'm doing something on it and my neighbor needs more power or from the millimeter waves, is it possible that my cell phone will ramp up its radiation because there's a link between different cell phones? And also the fact that they will be bouncing on buildings and different objects, these millimeter waves, so maybe that I'll end up in the beam still. Is that accurate, or?
It's partly accurate. I mean, there is, to that point, there is no protocol for transmitting through the other phones to the phone. So for that means it can be arranged, but from the perspective of the mobile network operator, it's not really effective, because if I have the MIMO installation or massive MIMO installation, I can better serve other customers from my mobile base station, than using the other mobile phone for transferring the data. But it can be easily done on the other way. So technologically it's possible. It's only a question if it will be, usable to the point that the mobile network operators will decide to use such a technique. As I said, the standard is not fully established. It's not fully established in details, so it's still a little bit of unknown how it will be in the final proposal. I mean, talking about the millimeter range.
Gotcha.
And the other question is, yes, it will be like that you that you will use, even the telephones, the new smartphones will use the beams reflected from objects, okay, to really be able to provide the service. And I will just go into that in just another slide, okay?
Okay.
Here I just want to show you that we are here like 2018, and it's already nearly 60 million units produced, okay? And 2024, it's 180 millions to be produced. This is what industry is already delivering to the telecom providers. So this means chips. This means special units which can be used now by the let's say mobile equipment producers to produce the mobile base station and other equipment, okay, antennas and so on. So it's going on already very strongly. And here you have the Qorvo FEM vehicle to everything trials for leading automakers, and you have the estimation made by Gartner that is estimated that it will be 200. Excuse me. 200 connected vehicles on the roadway. Okay, so it's not only coming, but it's already a part of our reality. And the Qualcomm chipset, which the article is talking about, is currently part of the trials underway with Audi, PSA, Ford, Nissan, and other ecosystem participants. Projects in Europe, North America, China, Japan, and Korea, so basically everywhere. And here you have this what I informed you about the radars used in the cars. Okay, so an article which I read, then it was. The topic was a radar in every bumper, and you can see that if you have adaptive cruise control, you have radar usually in the 77 gigahertz range, bandwidth, I mean, and with the range of 200 meters. And the same blind spot detection is using 24 gigahertz frequency or 70 already now. And other types of radars. And also the chart below says that that radar is actually becoming the more important than the LiDAR technologies, so based on light, and it's actually becoming an industry standard. And now simply the radar in the 70 gigahertz range, it's in nearly every compact car sold worldwide. If you buy, for example, I don't know, Honda Civic, then you have 3 of such, okay, at least. You have 2 for blind spot detection, and you have 1 for adaptive cruise control. There's no other way. And those radars, when the car is moving, so when the car is in the traffic, they are really radiating nearly constantly. Okay, I don't know how it is with the adaptive cruise control, maybe only on the highway when you put it on, but I am not sure if it's not also used in addition to cameras with the pre-crash detection and so on and so forth. So when you have high traffic on the city street now, the whole street is and the around city is really irradiated by this 5G millimeter wave frequencies. Okay,
And
from those antennas.
compared to what we can expect with 4K and 8K videos, can we say that this is way less power in the millimeter wave range, or do we know what the power density is, or it doesn't? And we don't. I'll let you explain why it's not necessarily the power density also that is the whole deal, but this is the question.
You see, in this in the radar in vehicles, actually the problem with the propagation of the millimeter range is used in advantage, because then you limit the radiation of the car to the certain range, and it does not interfere with the other cars. Okay, it only interferes in the very small space around the car. Okay, so maybe 200 meters in front and maybe 20 or 30 meters so the power density is not great. Actually, it's quite low, and the radiation quickly dissipates in the free space. Okay, but it's a lot of it. Yeah. So a lot of sources. Okay, so car by car by car and so on. So when you are into it, it's about the power density is not the only. I will revert to that if we have time, but it's not the only and even not most important thing in biologic impact of the signal. There are different other characteristics of the signal which are even more important than power density. We are so focused on power density, but the power density measurements actually comes from the idea that we have only thermal effects of the microwave. It doesn't take into account the information effect of the microwave radiation. So what is the signal characteristic? Okay, it has low power density, but then the impact on the human being is much greater than the other signal with even higher density. Okay,
gotcha.
And the radar is one of the examples, in my perspective and in my experience, which is the most deregulating signal for the human biology, because it's not. First of all, it has a very impulse character, so it's pulsed every time, and then you have also the in cars, and you have also, this is a source which is non-stationary, so it's completely artificial. It's not only that the source is emitting the mobile tower, it's emitting the certain frequencies with the power density. Here the source is moving. Okay, and the beam also of the radar in the car is also not like only the beam in one direction. It's like it's scanning, because with radar you scan. Okay, it's actually not realized mechanically like the old air traffic radars or something when the radar is rotating. Here you have many elements on the circuit board which are simply switched very fast, and they have beams in other direction. Okay,
gotcha.
So it's simply moving. So it's not about power density here. It's about the signal characteristic, which is the regulating. And with many sources, even with the small density, you have a lot of cars on the street, and you have a lot of radiation, which you are constantly into it. Okay. Gotcha. Either you are in the car, yeah. and when you are on the street also. Okay.
And Pawel, I think the first interview we did together really went deep into why power density is not the entire story, and how the signal characteristics really matter. So the frequency, modulation, pulsation, polarization, and these different things. And for people listening to this, if it's a little bit over your head, just understand that a signal can be low power, but it can be higher chaos on a biological standpoint. It's more confusion. So the more sources you have, it looks, and something I was listening to an interview of Professor Dimitri Panagopoulos from Greece, if I'm not mistaken, a great researcher, and he was simply saying, well, we know in studies that cells can recover from exposure to man-made any man-made EMF, but they try to recover, and then they have another chaos coming in. So they try to adapt, but we cannot adapt because of the unpredictable electrosmog environment that's always changing multiple times per second. So this is really, I just wanted to give a simple explanation for this phenomenon. But this is, do you know, so would your advice personally be to purchase an older car that doesn't have all these smart systems in that case?
Yes, that's one of the solution, actually.
Okay.
Because you cannot really control it. You know, I was out to buy a new car last year, and I spent with my spectrum analyzer. I spent like 3 or 4 hours at the dealer, measuring the car, the key system, the start-stop system, and everything. You know, with all my knowledge and all my equipment. And I had to accept that there are some things which I cannot really put out from this, but I made some special shields for the key system and for the immobilizer system and other things. So I am pretty okay now in this car.
Okay.
But still, I can switch off the radars. I can switch off the radars and do not use it. But you have to be conscious, and you have to do it every time you enter the car, because by default they are operating every time you start the car.
Wow. Okay.
So it's becoming tougher and tougher. And for me now, the best idea probably for the next car, this one actually, I was very aware. I tried to buy a model from 2017, not the 2018, because in 2018, from the April of 2018 in Europe, there is an obligatory law that the car has to have the SIM card for the mobile communication to inform about the crashes and so on. But what does it mean exactly is, you have the mobile interface in your car's computer, and you don't know how it will be used.
Yeah, exactly.
And not only by your car, but also for the car producer and something. And when this model is radiating, when it's located, and you have no control now. Okay, so it's very difficult now to find everything in the car and to really get rid of that. You cannot rid of the electronics, which is really built into the computer of the computer system of the car. So you cannot switch it off. Even with my knowledge, I can find it, okay, but I cannot eliminate it. Gotcha. Using the car. So the best way especially for the highly electrosensitive people is to buy a car like 5 years old, okay, and make it safe. And I am looking also for partners for making a garage, for measuring that and then installing everything. If I find the right partners, we can do such a company.
Perfect.
I think it will be many clients for that.
Sure. If there's engineers, anyone listening to this interview that wants to work on a venture for low EMF cars with Pawel, please get in touch. You're going to find my information on YouTube. Yeah. Or just write in the comments below, and I will put you in touch for sure. Pawel, I only have a few minutes left. Do you want to go into more slides?
I want to go in one slide, which is, okay, I think, the very, very important one to understand. This is 5G seriously affected by human body. Read that. And Rotten-Schwarz, which is the biggest top-shelf measuring equipment company, along with China Mobile and MediaTek, has successfully carried out a technical trial of a 5G prototype terminal. The main purpose of this trial was to verify the signal characteristic and propagation of the millimeter wave terminal in different environments, both indoors and outdoors, and to investigate the effect that beam tracking and array antenna switching have on maintaining the stability of the millimeter wave signal. So we have the real life trial with the prototype terminal like smartphone, and it's January 8, 2018. So it's new, okay? And then you have the results. and look at this red box. The result of the trial indicated that the millimeter wave signal can be seriously affected by the shielding effect of objects. The human body shielding can cause the signal attenuation to be as high as 10 to 20 dB. 20 dB is 100 times in terms of energy, in terms of power density. Okay, so it means 100 times of shielding by the human body. Okay, to solve this problem, further optimization of both the terminal and the network is required. For example, antenna designers may need to introduce more flexible solutions, such as multiply antenna arrays that enable discovering the strongest signal by switching between antennas. So it means, basically, first thing, it means human body is the barrier for the good 5G transmission. So probably the solution would be to get rid of human bodies, then the transmission will be good.
Exactly, that's a good one.
So it means, it also means that industry has a good transmission in the real world scenario. Yeah. So this is what I'm saying. The application is not really at the point when you can roll it out in the millimeter wave. They have problems with that you lose the quality of the signal because of the attenuation of the human body, but not only the human body. In millimeter wave, your typical window in your house or your typical wall in the house, it's really a barrier for the 5G millimeter wave communication. So we are, in a way, already shielded, but we are unshielded when we go onto the street. Okay.
Gotcha.
But in the house, the problem is that if you do not bring the millimeter wave device inside your house, then you are pretty safe. But the other problem is that we cannot measure that in that range with the, let's say, affordable devices. So you never know if you have such a device or not, especially when the production is going into hundreds of millions of units now. Okay, so you do not know really where the emitting device is, and you can bring it home, and then you are not really shielded. And the other statement is that the shielding materials used, most of them, of the shielding materials used for the shielding of your house, so it means the shielding paints and so on, will be even more effective in the 5G range.
Oh, okay, that's good.
Because so that's the point which I think many people miss. Because even if you do not shield your house, the wall and the glass and so on, it's much more shielding than it is in the current range. So for the millimeter wave, it's very difficult to go through the wall or go through the glass or things like that. Okay, it of course with the enough of the power density, it will go through it with a certain attenuation, but still we are pretty much safe inside house. The problem is that we cannot measure that now, so we do not really know what is going on around them, and it's growing like on the street, like with the car, with radars, and all this infrastructure is going all around us. And even if the signal is very low in power density, it's very dangerous. I just give you just a quick view on the one thing. Here you have the precautionary guidelines values from the European EMF guideline 2016. This is a document published on the PubMed, so very easy to find. But you can find here that, for example, for the daytime exposure, if you have the radio broadcast, the old radio frequency modulated radio, the daytime exposure biological limit is 10,000 microwatts per square meter. But for the Wi-Fi with the terahertz pulsation, the same is at the 10 microwatts per square meter. So already here you can see that 1,000 time difference is simply not because of the power density, but because you have 100 times less power density, and the same biological effect.
Yes,
okay?
and that's
So
a great point.
With the 5G signals, I expect to be even lower. So we should expect for the let's say majority of population, the limits would be just 0.1 or 0.01 microwatts per square meter for the normal population because of the signal characteristic. So very, very low. So we are not talking we are not talking about the effect of only about effect of shielding and the power density. We are talking that we have to really bring this signal very, very effectively down to not, for our biology to not be affected. Okay.
This is fascinating, Pawel. I have to go. I actually have to lend my mic to my wife who has an interview. And it's been beyond fascinating. Thank you so much. There are so many great takeaways. And below you'll find links to Pawel's website and anything you want to mention. Just right now, before we go, 1 minute, where can people find you? What you're up to? What do you want to share with the audience?
I think now that my email address is the main contact. I am still building my Patreon site, which will be called EVE, so Electromagnetic Vitality Engineering. This is a new approach or a way of discipline of thinking about the electromagnetic environment in terms of vitality and health and how those things impacting. It's basically, it's about, I just showed this one slide. It's applying signal theory, control theory, quantum electrodynamics, and EMF engineering to quantum biology, biophysics, biophotonics, and bioelectronics to understand and engineer vitality. And I also make another area of knowledge, which is called bio-EMC. EMC is electromagnetic compatibility. I am now thinking about and building, actually developing the field, what is the bio-electromagnetic compatibility. So what are the electromagnetic signals which are compatible with the biological with life, okay?
Very nice.
So you can reach me by my email and for now, and I think in a few months I will be ready to publish more in English on Patreon blog. That would be it. So that's basically it. We don't have time to
Perfect.
go further.
Perfect. Well, I'll have you on again. You can bet that. And thank you so much, Pawel, for your time, for having redone the interview after me kind of postponing 2 times. And thanks so much. This information is so valuable. I'll make sure to have your email and your links below the video. And thanks again. We'll chat again soon.
Thanks, Nick.
Thanks. Take care.
Take care. Bye.
Bye.